So now we're going to present our presentation that is talking about smart fan. And first, let me introduce ourselves. My name is Gloria Yoland Septryana, and my partner is Ardi van Sejati. And we are both from class 3 SC7. And now let's start the presentation with the system analysis of smart fan. So now the first thing that we would like to explain is about the system analysis of our project. Internet of Things or IoT is a computation concept of daily objects that is connected to the internet and can identify other devices. These days, Internet of Things is not a strange thing anymore. There are so many IoT systems that is applicated in our daily life, such as smartphone, laptop, smartwatch, even smart home or smart house. Rather than make a smart home system which is more expensive, in this project we will make an IoT-based home appliance system. Right now there are so many IoT-based home automation systems such as smart refrigerator, smart lamp, smart AC, and else. In this project, we will make a smart fan that will detect the temperature of the room, then decide to turn the fan on or off. For this smart fan, we are using two actuators and one sensor. The actuators that we use are DC motor, which is the fan, and relay to give signal current to the DC fan. Also, the sensor that we use in this project is temperature and humidity sensor, which is the HT11.
So in this project, the component that we are using are Node MCU or ESP8266. This is the DC fan, and then the relay for giving the signal from the Node MCU to DC fan. This is the temperature and humidity sensor that is DHT11, and battery for turn on the DC fan. This is the breadboard for the Node MCU, and this is the LED. The main function of the LED is for testing the connection of the internet if there is any connection. So LED will turn on. If there isn't any connection, it will turn off. So the platform and application that we are using are Tinger.io and Arduino IDE. So why we use Arduino? Because it's for code, and the Node MCU and Arduino are same same of environment. And why we use Tinger.io? Because in Tinger there is kind of like a full preview on the ESP8266 or Node MCU. So from the connection, from the sensor, and then the graphic of the sensor and connectivity, and the last thing is the map or GPS in Tinger.io.
Next, I'm going to explain about the flowchart in our project. So we have start here, and the first thing is the sensor or the HT11 will detect the temperature and humidity of the room, and then the HT11 will be having communication with Node and ISP. Because the ISP is not connected yet, so the LED is off. Because the LED that we use in this project is the function is to give us signal if there is any connection or not. Okay, you can see it here, the LED is still off, and then so there will be a connection to ISP, so the LED will be on because it is connected, and then if the LED is on and the connection to ISP is connected, in Tinger.io, it will be showing the temperature graphic in Tinger.io, and then Tinger.io will work to Node MCU, and Node MCU will work to relay. And in relay, we set it in our code that if the temperature in the room is start from 31.1 Celsius, then the fan will be on because it is hot enough of the temperature, so the fan will be on. And if the temperature is under 31, or 31.0 Celsius, the fan will not be on. So now I'm going to explain about our schematic system. First, we use the component node MCU ESP8266 with Wi-Fi, and then we use LED, which is green or else, and then we use the sensor DHT11 here that is connected to the node MCU ESP8366, and then the VDD1 connected to the power and GND connected to the ground. And then from node MCU, we're connected to the relay. It is the relay 1, and the relay is connected to the ground and also connected to the DC motor or DC fan and connected to the battery that we use as 9 volt. And yeah, that's it. So the picture that is shown here now is the real photo system of our smart fan circuit. And next, my friend Ardi will be demonstrating the smart fan works and how the program code works and also the Tinger IO.
And now we are going to test and demolition of our project. So the first is this is uh, my circuit of the node MCU, our circuit of node MCU. So the first is we need to heat up the heat with gas match. So we can gain the temperature. So we can see in the tinger.io there is only 30.3 degrees Celsius. So we're going to heat up to 31.1 degrees of Celsius. So okay. Now so the reading temperature in the node MCU is not accurate, so it's always 1 or 2 seconds slower. And then with the Tinger.io, it's up to connectivity from the internet. So we can see it's gaining to 31.1 degrees. So with the 31.1 degrees hit the target, so the relay will turn on the DC fan. Okay, and now we are going to place it the sensor to make it kind of like cool it down. Uh, so what if the temperature is below 31.1 degrees? So the nodium series will give the signal to the relay that need to turn off the DC fan. Okay. After this, okay. Now see, like now, right now it's turn off. So it will looping. So it's yeah, I think it's pretty much it. So back to presentation.
Now the conclusion and suggest. So the conclusion of this project is, we make an IoT-based home appliance system, which is smart fan, that we are using Node MCU, relay, and sensor, and humidity and temperature sensor with battery and other component like LED and else. And also we're using DC motor and DC fan or DC fan as our output. We got some mistakes. Uh, the first one is we're using Node MCU as our microcontroller that have a voltage is 3.3 volt, but we are using relay which is 5 volt. That actually the microcontroller can't handle the relay because the relay is having a bigger voltage than the not MCU. So maybe next time if we're going to make the other project, we should search for more information about the voltage and other information like voltage, current, and else. And that's all.